Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
Welcome back, team, and yes, we'll continue the discussion. And I hope the Kubernetes is little interesting, right? And yes, we'll continue the same, and we'll try to improvise our architecture further to, keep close to the real time how it is being used, right? So I'll be keep on asking you guys the questions just to understand, because I'm keep on improvising the stuff, right? I'm keep on changing my architecture as well, the way how we are running the application in the Kubernetes, right, day to day. Obviously, it will be like this, right? We can't jump on to the final stage just like that, right? We need to go through all these different levels and see or you know uh, solving the current challenges, and then we are improvising our architecture further and further. So being said that, at this time, right, at this time, whenever I'm running my application as a pod, right, in our Kubernetes cluster as a deployment, correct? So as a deployment, right, the deployment will now take care of running your application as multiple replicas based on the replica count that you have been given at the time of doing the deployment in your deployment manifest file, right? And then you access the application using the service that you have been configured, right? And preferably the load balancer type of the service, because that will take care of creating the the cloud specific load balancer as well, so that the application can be accessible via the load balancer, right? So that you don't need to worry about sending the traffic to the specific worker node per se, correct? This is the whole summary so far, right? And the question for you at this time, right? Uh, do you really worry about the worker node now? I mean to say, my pod is currently running in which worker node? Do I need to worry about that? You see, in this presentation, I actually removed my worker nodes from the presentation. Why? I'm not really worrying about the worker nodes at this time. No matter my pod is running in any worker node, it should be accessible. That's how your service is now taking the responsibility to identify the pod using the label and let route the traffic to that pod, no matter the pod is running in which worker node, right? That's the reason. So far, so good. So now let me go to the next step. So I have a bunch of slides. So let me pick up the right one, guys, to cover up the next topic. Well, so for now, let me see what is my Kubernetes cluster status. Then I will start doing the deployment first. So yes, my Kubernetes cluster is ready. So let me start accessing the cluster. As usual, I'm using my EC2 instance as a Kubernetes client where the kubectl is already configured. Let me run AWS EKS update hyphen kubeconfig hyphen hyphen name ed hyphen EKS hyphen 01 hyphen hyphen region US East 1. Good. So kubectl get nodes. Good. It is working. Now I wanted to deploy my application, right? As of now, kubectl get deploy. I don't have any deployments. kubectl get a service. I don't have any services. There is one service that is already there, which is the default service. Don't worry about this. There are no services that we explicitly deployed on this. It's a brand new cluster, right? Now let me deploy my application, guys. So I think this is where my deployment manifest file, correct? So I'm sure the file might be there here as well because the server is same. You see, so this is the deployment manifest file which is deploying the 3 replicas for me, and currently this deployment has the liveness and the readiness probes are currently configured, right? Let me deploy this. kubectl apply -f deploy.ml, kubectl get the deployment, kubectl get the replica set, kubectl get the pods. So far so good. Now currently my application is deployed to run as 3 replicas, right? Now later whenever you wanted to update the configuration of your deployment, right, how are you going to update the configuration without affecting the current application that is serving to my end user, right? That's where we need to go over with the update strategies that we have. So in the sense, right, when I say update, right, currently the application is deployed, right, using the deployment manifest files, right? Any change that you do for your deployment manifest file, that is considered it as a update. It could be a, right, it could be a label change, it could be a image change, it could be a, the liveness change, or you may be adding some other parameters, like I'm adding the, the resource limit and request, whatever it is. Anything that you are changing in the deployment manifest file, which will be considered as a update, correct? So let's say now I'm going to add these resource limit and request configuration to the existing application that is running over there, right? So what I do, I'll just update the manifest file like this. Hey, I wanted to follow this strategy, right? So probably I'll give the less number of CPU here, guys. Maybe I'll say 100 M is good enough. Maybe 50 M is also fine. Because my server is very small, right? I don't have much capacity over there. I'm just trying to make it less capacity. Yeah, this should good work. Maybe 10 MB, 1 MB is also fine, I believe, right? So now let me copy this latest manifest file. Let me go and deploy over there. So what I do is I'm going to update my manifest file here. I'm just removing the existing manifest file. Let me copy paste the new manifest file along with the resource definition changes, and the manifest file, sorry, the deployment name is same, guys, correct? Now all what you need to do is run kubectl apply -f deploy. That's it. What I'm doing, actually I have updated the configuration in the manifest file, then I'm applying this manifest file again, correct? Now the Kubernetes will understands that, right, the deployment name that you have used in this manifest file is already deployed in the cluster, correct? There is a deployment already running in the cluster with the same name. Then it understands that, hey, there is a deployment already there. Look like the configuration is modified. Let me update the configuration on the existing deployment. That is how the Kubernetes will understand, will try to roll out the change for you. Good. So when it is time to update the new configuration that you have defined in the manifest file to the existing applications, the Kubernetes may follow a different update strategies. There are two different, sorry, there are two strategies that the Kubernetes is supporting by native. One is called as a rolling update strategy. Okay. So rolling update strategy is the default strategy that the Kubernetes is following to update the configuration of the existing deployment, right? I mean to say, if you are not telling which strategy that it has to follow. By default, the Kubernetes is following the rolling update strategy. We'll see how the rolling update work. Right. So let's say currently you have deployed your old configuration, that is the current application that is running state, right? As we already know that whenever you have done the deployment will actually create a replica set. The replica set will be running with some specified number of replicas that have been mentioned. In this presentation, let's say you have deployed a deployment by specifying the replica count as 2. Then obviously the deployment will take care of creating a replica set with a replica count of 2. The replica set is now responsible to create a pods with the 2 replicas using the template that you have specified in your manifest file. The replica set controller will first create a pod and it will try to deploy and run a container inside, and application will be running fine. Let's say this application, I'm calling it as a V1. What is V1 here? Let's say this is one of the web application that you have deployed running with a version 1. Are we good with this? The replica set controller will now be deploying a one more pod, and the application will be bringing up on this pod as well, which is again a V1 only, because I said I need to have 2 replicas, right? The 2 pods will be get deployed using the same image, same configuration. That's where I'm calling it as a V1 version, right? The service may be routing the traffic to any of the pod out of these 2. The response will be the same. If you're not speaking, please be unmute, guys. Thank you. Right? So this is the current scenario. Now what I'm doing, I'm actually updating my configuration, right? I wanted to give the resource limit and request capacity. That's one of the change that I'm doing to my deployment. Whenever you update the manifest file and apply the new manifest file, the Kubernetes is going to understands that, hey, the the deployment name that you have specified is already there and look like the deployment is already running. Maybe I need to compare the existing deployment configuration with the new configuration that you are giving. If any differences are there, it is going to update the existing one. Are you good with this? In terms of it is updating the existing deployment with the new configuration that you are giving here, right? The very first thing that it is doing is it is going to create a revision. When I say a revision, in the sense, it is not going to disturb anything on the existing replica set, existing pods, guys. Rather, it is going to create a one more new replica set controller for you. It will create a one more replica set controller, keeping the replica count as 1. Right? This new replica set controller is created using the new template configuration. Getting me? Right? The new configuration, whatever you have been given in the new manifest file. Now in the new replica set controller, right, the pod will be get deployed and your application will be coming up over there, which I'm referring it as a V2 version. That means now your application is deployed as a V2 version, which is the new version or the new configuration, whatever you have been asked for in your configuration or in your manifest file, right? So now tell me, guys, at this time, how many pods are currently there in order to serve the traffic? 3, right? Because either it is a V1 version, the old configuration, or the V2 version, the new configuration. The labels are same, correct? I'm not changing my label. That is very important, right? As long as the labels are same for all these 3 pods, your service will detect that, hey, I have total 3 pods matching the label. Let me distribute the traffic to this. So the traffic will actually be routed to all the 3 pods at this time. And since the liveness and readiness probe is already configured, right? Whenever the V2 version application is really a healthy, then only the pod will turn into a running state and will start accepting the data, correct? Or the traffic. The moment when the V2 version of the pod is healthy, the readiness check is passes, is able to receive the traffic, is able to give the response, then it is going to update the old replica set controller from replica count 2 to 1. When it is updating the old replica set controller to 1, right, then the replica set controller understands that, okay, I need to maintain only one pod. Why there are two pods are running? It is going to terminate one of the pod from this list. Now at this time, how many pods are there, guys? In order to serve the traffic, there are two pods. One is the old version, one is the latest version, right? Of course, during this time, one user, whoever is accessing my website, may get a old version. The another user, whoever is getting my website, may get a latest version as well possible, right? Because the service may be routing the traffic to the V1 pod or maybe a V2 pod, right? Based on the request is going to which version of the pod, the end user, whoever is accessing the website, may be getting the response from that particular version of the pod only. That is still be fine because there is no downtime in this case, right? Either the user is getting the old V1 copy or the V2 copy. Somehow the website is working, the response is going through fine. After some time, of course, the immediate next second, the latest replica set controller will be get updated from 1 to 2. Then this replica set controller understands that, hey, I need to maintain two copies, but I have only one. It will go and create a one more pod with the V2 version configuration. Now at this time, there are three pods that are serving the traffic. The moment when the second V2 version of the pod is back to running, the readiness check is paused and is able to handle the traffic. The old replica set controller replica count will be updated from 1 to 0. Then the old replica set controller will be deleting the another pod as well because it has to maintain 0 replicas. So that will be get removed. Now at this time, there are two pods that are currently serving the traffic. The two pods are actually running with the V2 version. That means what? The update is completed. Can I say that the update is completed? Whatever the new configuration that you have been given, right? So your pods are currently running with the new version only. My old version is completely removed. This is called as a rolling update strategy. In this rolling update strategy, absolutely there is a zero downtime. Agree with me? Why? First it is creating a new version, then it is deleting the old version. At any given point of the time, definitely there is a pod that is available for you to serve the traffic. So hence this is no impact on the application when the rolling update is happening to update your deployment to the new version that you would like to. Whenever you are deploying the whenever you are updating the deployment, yes, it will ensure that the new pod is readiness check pass, the health checks are pass and able to start serving the traffic. Then only the old one will be get removed. For any reason, let's say the V2 version is not coming properly. The V2 version pod, the readiness check is failing for whatever the reason, then it will not be deleting the existing old replica. No, until unless the new version is healthy, the old replica copy cannot be deleted. That's how it will ensure that, right, there is absolutely zero downtime, because once the V2 is good, then only the V1 is going away, right? That's the reason. That is where configuring the readiness and the liveness probes are very important when you are doing the deployment. Then only it can ensure that the the pod is stable and healthy before it is actually removing the old copies. Yeah, good. Now let's say, of course, the readiness check is good, right? But sometimes, even after the readiness check is passes, the V2 version is running fine, is able to serve the traffic, but somehow you are not happy with the V2 version. Let's say somehow the second version, the latest configuration is not working as expected. Maybe the health checks are passing, possible, right? Sometimes the health checks may be passing, application may be working, but you may be having some other issues, right? You may be having some other issues, maybe a performance issue, maybe the code is not working as expected, right? Sometimes the pod is crashing very frequently. It is back to running and it is healthy. Let's say after 5 minutes it is crashing. Again it is backing up and it is healthy. Again after 5 minutes it is crashing. Maybe your code is not stable. Possible, right? So then you realize that, hey, look like there is something wrong in the V2 version configuration, what is being deployed. It's better to go back to the previous version, how it was before, so that I'll continue working on the code to fix the issues from the developer side. So whenever you think that you need to go back to the previous version of the deployment, right, then you ask the Kubernetes, hey, can you please go back to my previous configuration? So what Kubernetes will do, right? The previous configuration is already there, right? In the old replica set, because the replica count is become 0, but the replica set controller is not deleted. Getting me? In this case, the deployment is actually maintaining two replica sets. One is the old version, one is the latest version. Whenever you ask for the rollback to the previous version, right, then the old replica set controller will be updated to 1. The V1 version of the pod will come up. Then latest replica set controller will be updated from 2 to 1. 1 will be get destroyed. Again, the old replica set controller will be updated to 2. One other pod will come up with V1 version. Then the latest replica set controller replica count will be updated to 0, and this V2 pod also will be get deleted. Now the rollback is completed. Your application is fully running with the V1 version again. The V2 version is back to 0. This is called as a rollback plan. Even in the rollback plan, it is following the rolling update strategy to ensure that at any given point of the time, right, at least one pod will be available to serve the traffic. Hence, there is absolutely a 0 downtime. The deployment is going to keep all the revisions as a replica set controllers, right? The replica set controller itself is actually holding off your entire revision history, right? So it is going to, it is able to know that which revision that it has to bring up, and the Kubernetes will take care of all these things for us. By default, I do believe that let's say the V1 is there, then you deployed V2 version. Again, you do one another change that will become the V3 version. Again, you do one other change, V4 version, right? Something like this, correct? So each time when you update a configuration, right, that is treated as a new version, and a new replica set control will be get created. I do believe by default the Kubernetes deployment is going to keep the last 10 revisions. Last 10 replica set controllers will be there always. Always in the sense, if at all you have done more than 10 updates, right? So last 10 updates will be keeping in a record, and we can go back to any version that you like it, right, based on the situation. but most likely you may be needed only the previous version and the current version, correct? Usually it's very rare that you have to go back to the you know the the older version than the latest, sorry, than the previous one. It's very rare, right? Only the latest or the previous. But yeah, so it is going to keep almost 10 revisions in the history in order to keep track of the previous versions. Now,
So in any 10 versions it will hold, sir, any 10 versions. So if we don't make any changes, so last 10 changes will be there forever, or is there any retention for that? So it will get I mean, if you are not changing anything, it will get auto deleted kind of a thing.
usually, right, we don't need to have a requirement to keep the 10 revisions. Usually, as I said, right, either you keep the application to be running on the latest. If you don't like the latest, you go back to one level below. It's very rare that you go back to n-2, n-3, n-4, right? But yes, from the Kubernetes perspective, it is going to hold the 10 revisions always. And if you don't want, you just need to go and do the cleanup by yourself. Now, the Kubernetes is following the another update strategy, which is called as a recreate strategy. What is this recreate strategy? Let's say that currently the V1 version is currently running good. You do one change, right? You add some configuration change in your deployment file. Rather creating the new one first and destroying the old one, in the recreate method, first it is going to destroy the current one and then create a new one. That is called as a recreate method. In the sense, first the running pod will be get deleted, then it creates the new one. In the rolling update strategy, first it is going to create a new version, then delete the old version. In the recreate policy, first it is going to terminate the existing pod, then it is going to create a new pod. And of course, as it is terminating the existing pod, then creating a new pod, definitely it takes some time, right? The new pod will come into the picture and passing the health checks and serving the traffic. Yes, there will be 10 to 15 seconds or whatever the time that it takes, right? There will be a slight downtime in terms of giving the service access to the users. That's true. But based on the use case, right, which method may be suitable for our requirement, we need to adopt the one. But this is how it works. But the rolling update strategy is the recommended one most of the cases. But yes, we do use the recreate method as well sometimes. We will see in which scenario we will be using the recreate method in next lectures. But yes, definitely we will be using recreate as well at certain situations, and we'll talk about that use cases a little bit later time. Are we good with these two approaches? Now let's see, right, how the Kubernetes is going to do this rolling update strategy on our scenario, right? So currently the V1 version is deployed, let's say. Now I just have done some changes to the manifest file. Now I'm just running this command. kubectl get rs, kubectl get rs. I wanted to keep on running the commands, but it did very quickly. You see guys, the first time when I ran kubectl get rs command, you see that there is one new replica set controller got created, and you see that the 4 seconds ago a new replica set controller got created, and right, you see the old replica set controller is actually showing 1 here, correct? Why it is showing 1? By the time I execute the kubectl get rs command, it actually started off doing this rolling update strategy, right? This old replica set controller will actually come from 3 to 2, from 2 to 1, after then 1 to 0. Now I can see the 0 as well there, correct? So by the time I executed a command, it actually showing 1, and the latest replica set controller is coming with 3, and you see the latest replica set controller showing 2 pods are ready. That's the reason the old pod is still there. The moment when the 3 pods are ready in the latest version, the old version is become 0. Right? And of course, it's very fast. That's the reason, right? We can understand it using this kind of a presentations only, because when we go to the real-time implementation, right, it's very quick, and you see the things here. Let me clear the screen. kubectl get deploy. I have only one deployment in this case, but this deployment is actually taking care of 2 revisions. One revision is handling by one replica set controller. The other revision is handling by another replica set controller, which is just storing the configuration in it. And kubectl get pods. You see that all the pods are actually created 2 minutes ago, and you see that your new replica set controller created 2 minutes ago. That is just proving that the old pods were removed, the new pods are created with the new configuration that you have been given, which are handling by the new replica set controller. So as I said, whenever the new version is in running state healthy, then only the old one will be get deleted, or else no. I'll just try to prove one more time. I'll just do one more change, guys. Okay. Probably this time the change that I'm going to do is, right, probably I'll just change this to 5 seconds. Any change is fine. It can be even the image tag version as well, guys. Probably I'll show that now. Currently I have deployed a Apache HTTPD image. If you are not specifying the version, as you know, it is going to get the latest version, correct? So if I go back to the Docker Hub registry, right? So if I go back to the Docker Hub registry and search for HTTPD, correct? And this is the image that I am using today to do the deployment. The tag section will give you the different versions of the image possible, right? And if you are not specifying the version, I mean to say tag, it will be picking the latest version. That is also one of the tag. But we can specify the version as well. Let's say I wanted to use this version, right? So colon and specify the version so that it is going to get this particular version of the tag, right, and do the deployment. You can do that too. Any clue, guys? Why do a image has multiple tags like this? I think I have shown that in Docker concepts, right? So usually every time when there is a small change in the code, correct? Every time when there is a small change in the code, you need to build a new image out of it, correct? Right? So usually what is that you are doing? You are building the image from the Docker file, right? You take the default base image from the Docker Hub registry, then you are actually adding your code into a image and then creating a new image out of it, correct? So each time when there is a change in the code, yes, you need to build a new image out of it, and every new image will have a new tag, That's how it works, right? So let's say now I wanted to update the image tag so that it will get the new code, whatever is coming in this particular tag, right? So let me deploy this. Right? So I just have done some update to my deployment manifest file. Now I'm just running the command called apply. We'll see what will happen. kubectl get pods. I'm just running the get pods command quickly, guys, because it's very fast. Done. If we closely monitor the output here, right? First, it is actually terminating the, sorry, yeah, we can see that first it is actually trying to create a new pod. Once the new, this one, right? So first it is trying to create a new pod. Once the new pod is came running fine, then the one of the old pod is getting terminated, right? And again I can see there is a one more pod is back running here, and it is terminating the second pod. Again the other pod is coming online, then the another pod is getting terminated. This is just a rolling update strategy. It create a new pod, then terminate a one pod, the old version. So finally, after some time, you see that all the three pods are now running with the, almost 9 seconds, 6 seconds, 8 seconds. What does it mean? All the three pods are actually replaced with the new version. That's it. kubectl get rs. Now you see that the deployment is actually holding a total 3 revisions, means 3 replica set controllers. The latest replica set controller is now taking care of running our pods, which is created 86 seconds ago. There is one old that is called as a n-1 version, and there is one more called n-2 version as well, and it is going to maintain total 10 versions like this. Of course, we don't need to use all the 10 versions, all the cases, but that's how it is going to keep all the 3 versions or 3 revisions in this case, right? So in the each revision, it is just going to store the configuration, right? It's not going to store anything else. That means the manifest file, which manifest file that it has to use to create a new pod out of it, that configuration will be get stored in this replica set controller. We can see what is there inside actually. kubectl get rs. I wanted to know what is there in this particular replica set controller. Okay, maybe I'll take the latest one first, right? I wanted to know what is there in this replica set controller, and I wanted to get a output as YAML format. So the kubectl get command is to get the resource, and I wanted to get a resource called replica set, and this is the replica set that I'm interested to get the information, and that the output I need it in the YAML format. Now you see that API version is app/v1, kind is replica set, and it has some metadata, and somewhere you can see the labels, right? And you can see the name of the replica set controller, and you can see that the spec section maintaining, it has to maintain 3 replicas, and you see the specification. This is all about your the resources, which is the latest version. And you see the image, guys, the image showing that 2.4.58, that is the latest configuration that I have given, right? So that means what it is actually holding of the no, the holding of the actual specification of your deployment in the replica set, and then it know that how it has to create a new configuration. If you run the same command on the old one, let's say this is my old revision, right? kubectl get the replica set. I need the output in the YAML format, and you see that this is actually storing the configuration as HTTPD. The tag is not there. Even it does not have the resource limit and request as well, because this is the first version that I deployed. That is how it is going to store the number of revisions, guys, like this. So whenever you wanted to do the rollback, right? Hey, I don't want the latest version. Can I go back to the previous version? Either it is a rollback or it is a update. From your perspective, you just need to update a manifest file how you wanted it to be. Getting me, guys? Let's say now here I wanted to go back to the previous version, right? You really don't care about this number of revisions. To understand the concept, I'm telling that the Kubernetes is actually maintaining the multiple revisions. Each revision is managing by a specific replica set controller. It is storing that specific YAML configuration in it. But you will never worry about the replica set controller. You will never ever be working with the replica set controllers directly. Why? Are you creating a replica set controller by yourself, guys? No, right? You are always deploying what? You are deploying the deployment, right? Following me? I'm actually deploying the deployment. So you always be working at a deployment layer only. You are not supposed to work with the replica set controllers directly. In the sense, let's say in this scenario, I wanted to roll back to the previous version. All what I do is I will just update my manifest file how I wanted it to be. Let's say I don't want this version to be mentioned. I don't want the version to be mentioned, right? Don't worry whether you are doing the rollback or you are doing the update. For you, how your application is supposed to be, you do your changes in your manifest file and apply the manifest file. Let's say in this case, I'm actually removing the tag and I'm deploying. If I remove the tag, the configuration will be almost same as the previous one, correct? If I remove the tag, that configuration will be same as the previous one, correct? But I'm just removing the tag and I'm just deploying again. We'll see what will happen. kubectl get rs. You see that the Kubernetes is not actually creating a one more revision for you. You see, I'm not getting the fourth revision. I'm not getting the fourth replica set controller. Why? The Kubernetes can understand that the changes that you have been requested for, those changes are already saved as one of the revision in the existing replica set controller. So it will just go to that existing replica set controller. It will just try to bring up the pods over there. That's it. Getting me? If at all the Kubernetes identify that the configuration that you have updated in the manifest file, if that is not matching with any of the existing revision, then it understands that okay, this is the new configuration. Let me create a new revision. Let me create a new replica set controller, manage it. If the configuration that you are looking for is matching with any existing revision, then the existing replica set controller will be updated with the design numbers that will bring up the pod for you. Are we good with this? That means you are not working with the replica set controllers directly. No, always you define what is that you wanted in your deployment manifest file and go and deploy this. Either it will be a rollback or it will be a upgrade, whatever it is, manage it in your manifest file and update it. Kubernetes will handle behind the screen whether it has to create a new revision or it has to use the existing revision to bring up the pods by using the rolling update strategy. So if I look into my deployment, right, you can even run the kubectl describe command for all the deployments, sorry, any resource. Like how I have executed the describe command on the pod. Now I am running the describe command on my deployment. It's clearly stating that this deployment, the update strategy is rolling update. You see this? This is how you get to know that this deployment is actually following which update strategy to update the copies. I mean to say replicas, right? And down the below, you can see the events. This is where you get to see exactly what's happening. The deployment is actually, trying to manage the replica set controllers, and you can see how the replica set controllers are updated from 2 to 3, 1 to 2, 0 to 1, whatever it is. This is just to see the behavior, what's happening behind the screen by your deployment manifest. I mean to say deployment controller. Let me clear the screen. I'm just repeating some of the stuff now again, right? So the rolling update strategy, in the sense, whenever you do a change for your deployment configuration, the Kubernetes is going to update that configuration on the existing deployment. For that, right, it has to ensure that the new revision is created first, then the old revision will be deleted. And we have seen the recreate method as well. But there are few other deployment strategies are there which are called as a blue green and canary. These are the few different deployment strategies. Based on the scenario, based on the requirement, the people may use any method as well, right? So let's see what these are. The rolling update, we already got familiarized, right? The V1 version is deployed. When you deploy the V2 version, right, first one pod will come up in the V2 version, then the V1 version one will be get deleted. It will bring up the second version, sorry, second pod in the V2 version, then the V1 version will be get deleted. So simple, right? So this is all happening within your Kubernetes cluster, right? No matter whether the application is running with V1 or V2, at the end of the day, all the pods are running with the same label, correct? Because that is something that you need to ensure that the labels are not changing. Because the application will be accessible by the end user, right? The end user will always be accessing the application through the label concept only, correct? You see this scenario? Somehow the traffic will come from the end user, route 53, maybe the application load balancer, it will go to the services, right? Then the service will try to access the application using the label concept, something like that. There is one other ingress component there. I'll talk about that later. That's okay. When it comes to the blue green, right? In the blue green, right, the V1 version will be currently running, will be accessible using the same flow. The end user traffic will come via the route 53 to the AWS load balancer. From the AWS load balancer, the traffic will be routed to the application, right? So it's good. Whenever you wanted to do the update, right? Whenever you wanted to do the update, you create a V2 version, right? You create a V2 version. You see the difference? I'm not disturbing my V1 version, that is still be running as it is. I'm creating a V2 version. then the V2 version will be accessible over a different load balancer altogether. That means V1 version, V2 version, both are running, both are accessible using the dedicated load balancers that have been configured. Then which version that you wanted to access, you define that at your Route 53 level. Getting me now? In your Route 53, if you say that your domain name has to be resoluted to V1 load balancer, then the end user will be getting the service or the website from the V1 version. In your Route 53, if you say that the resolution should be for a V2 version load balancer, then the end user will get the V2 version application. Getting me? That means in the blue-green method, right, the both versions will be up and running at the same time. V1, V2 both are running fine. Which version that you want to access, you decide from your Route 53 level. One is blue, one is green. At any given point of the time, only one version will be serving the traffic, either V1 or V2. Whichever the version that is currently serving the traffic, that I'm calling it as a green. Whichever the version that is still there but it's not serving the traffic, that is called as a blue. That's why it is called as a blue-green environment or blue-green strategy. You take the decision at a Route 53 level which you wanted to. Let's say once the V2 is deployed, which is running fine, in the Route 53, you update a resolution pointing to the V2 load balancer. If you don't like the V2, for example, it's not working as expected, you wanted to go back to V1. The V1 pod is already running, right? It's just matter of updating the Route 53, sorry. It's just matter of updating the Route 53 pointing to the V1 load balancer. That's it. Now you continue accessing your V1 application. Usually when you are switching the, again, when you are switching the DNS entries between the blue to the green, yes, there will be a slight glitch will be there to the application whoever is accessing, guys. I will not call this as a downtime, but there will be a slight glitch, right? Exactly when it is doing the switching, so there will be a small glitch to the users. Maybe application maybe gets loaded very slowly, or sometimes application may get a 500 response code. The next second again it may be a 200 response code. It will not be that much downtime significant, but yeah, there will be definitely some glitch will be there during this transition time. Now sometimes, you know, I have got the V1 version, now I got the V2 version. Maybe I don't have confidence that my V2 version is working fine. Getting me? I don't have confidence that the V2 version is working as expected. It can serve the traffic to my end users. So that's the reason I may prefer the canary deployment sometimes. In the canary deployment, what I'm trying to do is, like blue-green, you maintain two versions. Ensure that the V1 is working as expected. Ensure V2 is also working as expected. Both are serving the traffic on its own load balancers. In the Route 53, you put a resolution for both. Right? And the Route 53 can support weight-based policy condition. That means It is possible to add two ALBs to the single resource as a resolution, and you define the route, the weighting, or I mean, it is a weight-based policy that, let's say, a V1 version should get 95% of the traffic, V2 version should get 5% of the traffic. That's how we can maintain the distribution of your traffic to V1 and the V2. Why do I need to do this, guys? Let's say there are 100 people that are accessing my website. Now I'm trying to make some change in my website code. Obviously, if the code get changes, you'll get a new Docker image tag. When you get a new Docker image tag, you update the new tag in your deployment file. When you update the tag in the deployment file, that will become the V2 version. When the V2 version is deployed, right? Let's say if you remove the V1 completely, right? What is the case if my V2 is not working as expected? All the 100 people will be affected, correct? All the 100 users, whoever is accessing my website, will be now routed to the V2 version. For any reason, if the V2 version code is not working, all the 100 people will be affected. To avoid that, right, we can go with the canary deployment strategy. Keep the V1 as it is. You deploy V2. You say that only a 5% of the traffic may go to the V2 version. So out of 100 people, 95 requests will still go to V1. Only 5 people requests will come to V2. Let's say for any reason the V2 version is not working as expected. Some code issue are there. How many people will be affected now? Only 5 people will be affected. The rest of the 95 people are still getting my old version happily, right? Let's say once you get the confident that the 5% of the people are accessing my website without having any issues, the V2 version looks good, all good, then you slowly increase the percentage. The V1 version you make it as 80, V2 version you make it as 20. After a day, once you get a confident, V1 version you make it as, let's say, 50, V2 version make it as 50. After another day, V1 version you make it as 10, V2 version you make it as 90. After another day, you make the V1 version as 0, V2 version as 100, so that the complete migration is completed. All the traffic is now going to V2 version only. You are gradually increasing the traffic to the new version rather a one time. It's a safer bet sometimes. It's up to the project, up to the requirement, which method would be ideal. Each method has their own pros and cons, but 80% the people will be preferring the rolling update strategy, which is seamless, zero downtime almost, right? But sometimes, the rolling update strategy may not be suitable as well. So the people will prefer the canary or the blue-green deployments. Are we good with this, understanding the concept? I'm not going to show you blue-green and the canary with the actual implementation for now. Just understanding this concept is good at this time. So I'll try to talk about these deployments a little more information and later when I'm coming into a project mode. Okay. For now, this is good to have this information. Yes, as I see a question in the chat window, yes. Right. If I go to the blue-green or the canary deployment, when I say V2 version, that is altogether a new set of infrastructure, right? Obviously, your cost will be go double because you are maintaining V1 as well as V2. You need to pay more, right? Your cost will go double. So that's the reason, right? Whichever is more comfortable in terms of the cost, in terms of the performance, in terms of the application nature, the people will prefer which one will be ideal for their use cases. But mostly, as I said, rolling update strategy is the preferred choice. Sometimes the rolling update strategy will not be ideal. I'll talk about that when rolling update is not ideal. I'll talk about that condition later. I need to talk few other dependencies before I come to that stage. So as I see a question in the chat window, and most likely the people are following this blue green or the canary, right, in the production only. I'm not really not worried about the dev environment, right? In the dev environment, I don't need to really care about this much, right? I'll delete my V1, I'll put my V2. If V2 is not working, no problem. I delete my V2, I'll put my V1. I can do whatever I wanted to uh, on my non-prod environment, correct? Because that is not really affecting my business. That is just internal. My employees, my developers may be affected. That is still be fine, right? So these strategies are really applied for the production environments, which is actually impacting to the end customers. If you wanted to apply the whole strategy even for the dev, no one is stopping, but that is unnecessary increasing the cost. You getting me, guys? Right? Implementing this whole best practices even for dev, it will be increasing the maintenance, right, and the costing all these things. Why should I be putting all those things for my dev? I'm not caring about my dev that much, even if it is causing some issues. So these strategies will be applied only for the production, which is really mandate. Now, now I'm jumping on to one more new topic in the Kubernetes, which is called as a namespaces, which is going to give you a few more confusions. Let's say I have got the code from developer and you keep the code in a Docker image, you prepare a Docker image, the image is ready. That image now I need to deploy it into the Kubernetes, but as you know, right? First you need to deploy that image to run as a dev environment, then to the QA, then to the perf, then to the production, correct? I have shown that as well in the Docker world as well, right? So first I created a dev container, then to the QA container, then the perf container, then the prod container. Same thing, but now I need to create it as a pod, correct? Not even pod. I think my terminology has to be get changed now, right? So I need to deploy my image as a deployment, correct? Because I'm not creating a pod manually, right? I always do a deployment. When I do a deployment, the deployment will take care of creating a pods for you with the help of the replica set controller and how many replicas that you wanted to. Agree with me? So now my terminology is I'm going to do a deployment. That means once the image is ready, first you need to do a deployment to the dev, then deployment to the QA, then deployment to the perf, then to the production. Agree with me? Right? Let's say you do the deployment to the dev, one pod will be created. After that, you do the deployment to the QA, then you do the deployment to the perf, then to the production, something like this. The problem here is how do you know which pod is for dev, which pod is for QA, which is for production. Getting me? Of course, I'm running with 3 pods. That is good. But which pod is accessible by the dev URL? Getting me? Which pod is accessible by the QA URL, which is for production URL? So it's very difficult to manage the deployments of multiple environments, right? Running it as a, without having any isolation in between. I'll show you in practical how it is. For example, I'll go to my deployment manifest file. Let's say this I wanted to deploy to the dev first. Okay, I'll do the cleanup first. I don't want this to be. Everything is gone. Okay. Now let's say I have got my image ready, and this image I wanted to deploy it into the dev environment, right? So maybe this is the deployment manifest file, correct? So probably for my deployment, I will give the name like this, dev web-dev. Good. I'll copy this. I'll deploy this. Let's say kubectl, sorry, deploy-dev.ml file. This is the dev deployment configuration manifest file. kubectl apply-f deploy-dev.ml, kubectl get deployment, kubectl get pods. So far so good. Right? Now you deploy a service, and that service will take care of routing the traffic to these 3 pods, and you can access this application from the external world. I'm not bringing the whole concept every time. We should assume that, or you should visualize that how the request is coming from route 53. Yes or no, guys? Same thing. In the route 53, you define a URL dev.edshopper.com pointing to the load balancer, then to the service. From service, it will come to your pod running your dev application, right? Now, I wanted to deploy this to the QA. Any help, guys? Can I get some help here? If I want to deploy this to QA, can I just change this name over there? For example, deploy-dev.ml file, right? Can I do a change here? I think I'm disturbing my dev file, right? No, I should not do that. This file is maintaining the dev environment configuration, right? I don't want to do any changes to this. So that means I need to maintain one more copy, right? Deploy-dev, I'm copying it as a one more configuration file as qa.ml. Now you open the deploy-qa.ml. Maybe here I'll do the change. Agree with me? So I'm deploying the new deployment with the new name. I'm maintaining the name as web-qa. This is for QA deployment, and I need 3 replicas in my QA deployment and some of the labels, all these things. Now a question for you at this time, can I use the same labels, guys, like this? In the dev deployment, I used the same labels, right? Now in the QA, can I go with the same label? Okay, for now I'm keeping the labels are same. Let me see what will happen. kubectl apply-f deploy-qa.ml file. Let me clear the screen. kubectl get the deployment. Now I have got the dev deployment and I have got the QA deployment. kubectl get pods. You got total 6 pods, 3 for dev environment, 3 for QA environment. Now, all these 6 pods are having the same label, right? In this case, agree with me? Because of course I have maintained two different deployment file, one for dev and one for QA, but I actually maintained the same labels in both cases for pod labels. So all the 6 pods are running with the same label now. The problem is when a service is trying to route the traffic, the service will now be routing the traffic for all the 6 pods, correct? Because the labels are matching. So this is very much confusing for me to maintain the multiple environments of your same application, correct? One biggest trouble here is now I need to maintain a different labels for each and every environment. If you're not maintaining the if you're maintaining the same label, the problem is the service will route the traffic for all the pods. Then where is the isolation for me? Because when someone is accessing dev.edshopper.com, that request should only be coming to the dev pod, right? But here what's happening? The request may go to any pod because the labels are matching. So it's very difficult to manage the unique label for each and every environment. That's one biggest challenge. The second biggest problem here is when you get to see the whole number of pods in one single listing here, how do you know which pod is for dev, which pod is for QA? Getting me, guys? Except this naming convention, correct? Except this naming convention. Do you have any other way to identify which is for dev, which is for QA? No, right? So it's not a good idea to rely on the naming convention to understand which is for dev, which is for QA. What is the case? If you are not maintaining a proper naming convention, then it's very confusing for me to understand which is for which environment. Hence the reason the Kubernetes has introduced the concept called namespaces. The namespaces are the logical isolation layer that the Kubernetes is providing to group the pods. Then you don't need to do any changes from dev to QA to the production. You can maintain same labels, you can maintain same naming convention, you can maintain same configuration, but it will not be having any conflict if you keep them in the namespace. In the sense, you deploy you deploy the 3 deployments. One is for dev, QA, prod, but keep the deployment inside a namespace. You create one namespace and you give the name for the namespace, maybe a dev namespace. Inside the dev namespace, now I'm putting my deployment. You deploy another deployment that you put inside a QA namespace. You do one more deployment. You keep that inside a production namespace, something like this. The namespace is acting as a logical isolated wrapper, right? Which ensures that the pods are completely isolated from one namespace to another namespace. That way, we can use the same name across the namespaces. We can use the same labels across the namespaces. It is not going to harm anything. I mean to say it is not going to give any conflict for us. Of course, the namespace is happening within your cluster. Everything, whatever I'm talking is happening within your Kubernetes cluster, right? Let me try to follow this namespace concept now to deploy my application. I'm just doing the cleanup, guys, because I created them just to show you what is the problem of running the applications directly of different environment. Now I'll try to maintain the namespaces. So if you have any specific questions, do let me know. I'll be on mute for 30 seconds.
So one cluster with 3 different environments, right, sir?
Namespace is the namespace is the logical grouping of your pods. The number of pods that you are deploying will be get logically grouped based on your requirement, right? Let's say I wanted to group all the pods belonging into dev it into one namespace. I wanted to group all the pods belonging into QA it into another namespace, like that, right? We are just making them it into logical grouping to make the things smoother, right? But it's up to you whether you use namespace or you don't use. But in the real time, the namespaces are used for the environment specific separation. We'll get to know what does it mean by now. Let's say I'm going to create a namespace first. Okay, so API version is v1, kind is namespace, metadata, the name of the namespace, let's say dev. Simply I have written one manifest file. So ns.ml. kubectl apply -f ns.ml. So the dev namespace is created. If I do kubectl get ns, this is the command to get the namespace list. Don't worry about the other namespace list that you see. You just focus on the dev. You see the dev namespace is created 6 seconds ago. Same way, you can create a one more namespace. You just need to change the name. Let's say QA. This is the manifest file kubectl apply -f ns-qa.ml. kubectl get the namespace. You see that the QA namespace is there. A question at this time for you. Whatever you are deploying using the manifest files like this, it can be a pod or a deployment or a service, whatever it is. Can I create the same using the kubectl command directly, guys? Possible or not? It's possible, right? The only thing is running the command directly is very tricky by giving all these number of flags. That's the reason we are taking the ML formatted file, right? But everything is possible to use the kubectl command line to deploy this case. Just to show you one example, kubectl create ns. I want to create a namespace. Let's say the production. You see, it's created, right? The prod is created. Anyway, I got my namespaces already. Now when I'm deploying my application, right? Let's say I wanted to deploy the application it into a dev environment. Okay. So this is my dev environment, right? You see, I'm not really following any naming convention. I remove the dev as well. My deployment name is web. My labels are app:web, and I'm just deploying this. My deployment manifest file is not actually maintaining any naming convention specific to the environment. Okay, this is very generic as of today. Now what I can do, right? Let's say if I wanted to deploy this it into dev, kubectl apply -f deploy.ml, sorry, deploy.ml. All what you need to do is -n, specify the namespace. Now your deployment is actually deployed inside a dev namespace. Dev namespace is a logical grouping of your deployments. Now the same deployment file without any changes, I can deploy it into a QA. Same deployment file without any changes, I can deploy it into a production. Now if you do kubectl get pods, let's say I wanted to see my pods. Kubectl get pods command is not showing any pods. This command is saying that, hey, there are no pods currently found in the default namespace. That means what? Whenever you set up the Kubernetes cluster the very first time, by default, there will be a namespace called default. The namespace name itself is the default. That namespace is being used by default whenever you deploy anything. Either you create a pod, whether you create a deployment, you create a service, or you create anything that you like it. In a Kubernetes, anything that you create as a resource will definitely be deployed it into a namespace. If you are not explicitly defining one, no problem, it will be get deployed it into a default namespace. So far, I was deploying the pods, deployments, all those things, right? Everything were deployed it into a default namespace, and it was showing you by default when you run these commands. But now I deployed my deployments it into a specific namespace, right? To get that, you need to specify the namespace as well. Hey, I wanted to get the pods running in the dev namespace. I wanted to get the pods running in the QA namespace. I wanted to get the pods running in the production namespace. You getting me now? That way, the pods are actually logically grouped it into a specific namespace. It's very easy for us now to work on which environment. If I say, hey, can you go and do some changes to the dev environment? You just go to the dev namespace and see which pods are running over there and do the stuff there, right? If I say, hey, do something on the production, you go to the production namespace and see the pods that are currently running in and just do the things. That way, the environments are actually isolated completely without any conflict. You don't need to maintain any naming convention. We don't need to worry about how to identify which pod is belonging into which environment to, because you took care of that by using the namespace as a uh, logical separator. Yes, if you are already familiar about the Terraform workspace concept, yes, kind of the same concept here as well. Namespace is not at all a concept called directories in the Linux system, no. Right? The namespace is one logical grouping of your pods just to make the things separated. So it will be easier now to work with the pods. Whenever I say, hey, can you go and do something on the dev, you just run the command called kubectl get the deployments in the dev namespace. You will get to see only the dev namespace specific resources. You will not see a QA and prod and all. So it avoids the confusion, right? It makes so clear for us to work on which environment always. Now let's say I wanted to access this application using a service, right? Now I need to deploy a service, right? Correct. So As of now, I deployed my deployment. To access that, I need a service. This is my service manifest file, correct? Copy this. So kubectl apply -f. I want to deploy a service to access my application. Which application that you wanted to? I want to access a dev application, right? You deploy it into a dev namespace. Kubectl get service on dev namespace. So this service is now responsible to route the traffic to the pods matching the label, but it is going to check for the pods within the same namespace by default. Getting me, guys? Can I say that here all the pods running in dev, in QA, in prod having the same label? Yes, right? I did not do any changes to my labeling, right? All the pods are running with the same label, but do you think this service is going to route the traffic for all the pods? No. Now, because I have restricted the services inside a namespace, this is by default checking on the dev namespace only. The traffic will go to dev pods only. It will not route to QA and prod. So that's a advantage now, having this namespace as a separator to separate your environment specific deployments. Now, if you want to access a QA application, you deploy a service it into a QA namespace. You deploy the service it into QA namespace. That takes care of identifying the pods within the QA namespace and route the traffic. That's how it works. The same thing, whatever I did it before, I'm just trying to make them it into a environment specific using the namespace here. Maybe the time for you to show this. Let's say you have a Kubernetes cluster. Of course, before coming to that, just to answer your question. Sorry. You see, guys, I'm getting an error when I'm deploying my service it into a QA namespace. Why do so? Of course, the Kubernetes specific, it's all separated by using the namespace, but these are actually binded to the node port, right? The node port is actually the port which is outside of the Kubernetes at a worker node level. It cannot be duplicated, right? That's where it is complaining. And of course, now you need to maintain a separate port number for environment to environment, or at least a service to service. That's true, or else it is complaining. That's a problem, right? That means in your Kubernetes cluster, whenever you are running the application, let's say first you deploy your application it into a dev environment, right? And you deploy the service in the dev, I mean to say namespace, the service of type load balancer, for example, that creates the AWS load balancer for you. You map that AWS load balancer it into www.etshop.com. Maybe let's assume this is a production, okay? Because I'm using www, okay? So let's say this is the production. www is now resoluted the traffic to AWS load balancer. AWS load balancer is routing the traffic to worker node. From worker node, the node port is binded to the internal load balancer service of your Kubernetes, and that is routing the traffic to the pods based on the labels that it is matching for. This whole stuff is happening within your production namespace. But the node port number, right? That node port is not within the namespace. The node port is not within the cluster, right? The node port should be a unique queue which is listening at a worker node side, correct? That means now when you deploy a, what's happened? That's okay. So when you deploy the deployment it into your specific namespace, let's say dev namespace here, you create a service, right? You create a specific node port and that will be get resoluted. When you deploy for QA, this is the problem now. The node port has to be changed, correct? If I use 31,000 node port for my dev service, I can't use 31,000 for my QA service as well. Hope you are following me now. The dev service should be listening on 31,000, let's say. The QA service should be listening on maybe 32,000. The production service should be listening on maybe 31,500, something like this. It should be something different because the node port should be in a queue because that is something listening at a worker node side, right? That no, the traffic that is listening on which number should be get mapped to which service behind the screen, correct? Based on that, the traffic will be coming into your actual pods wherever it is running. Not really, right? The node port cannot be the same at this case, correct? Same concept that I talked about in the Docker world. Whenever you are trying to access a application running in a container, you should have a separate port number when you are doing the port mapping, correct? Same thing. Any traffic that is coming from outside world to inside a Kubernetes cluster using the node port, that node port should be a unique queue, right? That node port will decide the traffic should go to which service inside a Kubernetes. That's how the binding is happening. It's difficult, right? Maintaining a different port for each and every service. How do you know how to maintain a unique port number? How do you know which port is already used, which port is not used? If you have total 50 services like this, let's say, will you be using 50 unique ports? It's really challenging, right? It's really challenging, right? There are two challenges at this time, guys. One challenging is maintaining a unique port at each service side. If I'm running 50 applications, 50 services, 50 node ports, 50 load balancers, 50 AWS load balancers, correct? So the two problems is maintaining a unique port is one problem. The second problem is maintaining the AWS load balancers. To access three services, if you maintain three load balancers like this, unnecessary, I'm putting more costing for my AWS side, correct? I need to pay for total three load balancers. Getting me, guys? I need to maintain total three load balancers here to access my three services within your Kubernetes cluster. So the maintenance is more, costing is more, right? And maintaining the unique node port is also one of the problem. So this is not a recommended way to access your applications. Of course it works. This is not a ideal way to access the application.
Hey, Pierre, I have a query. So, why do we need like n number of load balancers? We can also do the load balancer URL and then colon and then the each port number for every environment, right? That can also be done. Let's say there are four environment and four different ports. So can
The
we do like that, like with a
the
single load balancer
AWS load
command?
balancer, sorry, the AWS load balancer is now taking the responsibility of getting the traffic from the public internet space and giving that traffic to inside a Kubernetes to one of the service. That is the responsibility of the AWS load balancer here. At this case, if at all you are using one single load balancer, do you expect that this load balancer is routing the traffic for different services like this? It cannot. Why? Whenever you create a service in the Kubernetes of type load balancer, it actually creates the corresponding load balancer for you. That mapping is done. One AWS load balancer cannot be binded, cannot be mapped to multiple services of your Kubernetes. Technically, it's not feasible, right? Because if I want to access the dev application, my request should come to the dev service. If I want to access my QA application, the request should come to QA service. If I want to access my production application running in the production pod, the request should come to a production service, correct? If that is the case, the request whoever is accessing from outside world, right? How would you ensure that the traffic is coming into your specific pods using these services? Definitely you have multiple services like this, correct? Because I can't expect that one service is actually routing the traffic to the different pods, correct? One service cannot handle routing the traffic for dev, QA, prod, right? All are running in the different namespaces, all are different applications altogether. So every application has its own service, and every service should be having its own binded load balancer as well as of today, which is not recommended. I'll be improving this architecture further, but as of today, this is how it is. I'm just calling out the challenges that are there in this method. Make sense? One AWS load balancer cannot be binded to multiple Kubernetes services. Did that happen here? When you deploy the service of type load balancer, what happened, guys? When you deploy the service, you will get one AWS load balancer. That AWS load balancer is binded to this particular service in your Kubernetes. It know how to get the traffic from that. Make sense?
Yeah, but that was a classic load balancer. I mean, classic load balancer can only route to a particular port. But I'm thinking in a different way, like, can we utilize the concept of target groups? But I think it will be very complicated, yeah.
Either the classic or a application load balancer or a network load balancer, it doesn't matter. At the end of the day, for your AWS load balancer, your EC2 instances will be the target. Any load balancer that you choose, right? The target will be your EC2 instance. The EC2 instance will be a direct target, or it is part of the target group, then it will become a target. That is just architectural differences. At the end of the day, for my AWS load balancer of any type, the target is my EC2 server. The request that comes to the load balancer will come to my EC2 server, to the specific node port. That port is binded to the specific service of load balance, service of Kubernetes that has a specific routing based on the labels that it sees that. Make sense?
Mhm.
Of course, I'll open the question hour once I cover this slide. The actual implementation will be happen tomorrow. whatever you are expecting, like one load balancer can route the traffic to multiple services, all these things, right? That will be possible with the introduction of ingress controllers in place. You'll see now the way how the ingress controller works. Let's say you have a application 1 and this application will be accessible on one service. You have application 2 which is accessible on another service, right? So as of today, what I'm saying, you deploy the load balancer type. Each load balancer type of the service will be creating its own corresponding AWS load balancer, and you maintain the resolution accordingly in your DNS, right? The request that comes to the first load balancer will be routing the traffic to the first service going to the first app. The request that comes to the second load balancer routing the traffic to the second service that is going to the second app. This is what we have done so far, correct? I'm just repeating the stuff. Just to avoid all of these confusions, right? What we can do, right? You keep only one AWS load balancer. I need only one load balancer because the load balancer purpose is here, get the traffic from public and give it to my worker nodes, correct? That can be done by one single load balancer. But from the technical perspective, right, AWS side load balancer cannot be binded to multiple Kubernetes services. Getting me? I can't ask my AWS load balancer to give the traffic to different services of your Kubernetes. No, that's not possible. Why? Do you think the AWS load balancer will see the Kubernetes services? Do you think the AWS load balancer can understand Kubernetes or can see the Kubernetes? No, right? The time to go back to one other slide like this. You see this scenario, guys. The AWS load balancer can, or the AWS load balancer is responsible only to route the traffic to the node port of your worker node. That's it. Getting me? AWS load balancer will never worry about your Kubernetes services. AWS load balancer is responsible just to route the traffic to the node port of your worker node. Now, once the traffic comes to the node port, then it's a Kubernetes responsibility to take the traffic and give the traffic to the service, whichever the service is actually binded on that particular port number, correct? If you understand this concept, now do you think that using the classic load balancer or using the application load balancer or maybe any other type, do you think it makes any difference for me, at least from the Kubernetes perspective? No, because any load balancer is just ensure that the traffic is given to the node port of your worker node. That's it. After that, what happens? Your AWS load balancer doesn't know anything. It's a Kubernetes responsibility to take this data and give it to the service. So your node port is actually binded to one particular service only, right? I can't use this 31,000 port number binded to multiple services. Getting me? That's the limitation. One port number can be binded to one service only. Now going back to there again, how I'm going to solve this problem. I'm going to deploy a ingress controller in your Kubernetes cluster. The ingress controller will actually be deploying a service of type load balancer for you automatically. Think of like I'm creating a one other load balancer type service with a additional extra configuration called as a ingress. Whenever the ingress controller creates a load balancer type of the service, you all know, right? The load balancer type service will be binded to a specific node port and the AWS load balancer will be get created, correct? You see this scenario now. The traffic will come to AWS load balancer. That traffic will come to node port of your worker node. That traffic will now come to load balancer type of the service that is now being managed by the ingress controller. That way, either the people are accessing application 1 or application 2, both these are updated or resoluted to the single load balancer. In your DNS, you maintain that app 1 or app 2, both are actually resoluted to the same load balancer endpoint. The traffic will come to the same node port. Any website, the traffic will come to same node port. That traffic will come to ingress controller now. Now you decide in the ingress controller level. In the ingress controller, you now define a rule saying that, hey ingress controller, if you get a traffic for application 1 endpoint, if the request URL is application 1 endpoint, then you please route the traffic to application 1 service. If you get to see the request is coming for application 2, then you please take care of routing the traffic to application 2 service. What I'm doing, I'm putting one other extra service inside my Kubernetes, which is now taking care of routing the traffic to the backend actual services based on the incoming request URL. The outside of the Kubernetes, I'm using only one single load balancer, which is taking the responsibility of, right, bringing the outside traffic to inside a Kubernetes. Once the traffic is came to inside a Kubernetes, I'll use my ingress rules here to split the traffic to wherever it has to go based on the incoming request URL. Now you get to know why I'm using one other load balancer type here, because a AWS load balancer cannot be binded to multiple Kubernetes services at same time. No, that's the reason you take one other extra load balancer, but the load balancer, sorry, you take one other extra load balancer type of the service in the Kubernetes, but the load balancer type of the service is not capable to route the traffic based on the incoming URL, right? That is the reason I'm taking the ingress concept here. The ingress will do two jobs here. One job to create a service of type load balancer, which creates the AWS load balancer 2. The second job, it actually monitors the incoming traffic, can decide the traffic should go to which service out of the two services that are available in this presentation. Sorry. That way, I'm solving two problems. One, now let's say I have some 50 applications that I wanted to access from outside world. Do you need to worry about maintaining 50 node ports? No, right? All the traffic is actually coming through only one single node port. You are not maintaining multiple node ports now. No. Why? Internally in the Kubernetes, you are actually taking care of how to split the traffic. Rather, you are taking care of it outside of the Kubernetes. The second problem that I have solved here is I don't have multiple AWS load balancers. So one single load balancer is taking care of everything, and you take care of the ingress rule within the Kubernetes using the ingress controller. So that is what I'm going to set up now. So any questions, do let me know, or else I'll try to deploy this ingress tomorrow.
Sir, this ingress control load balancer that you have told, this is one more layer deployed at the cluster level, right? And we have to define things there, right? So how it
Yes,
needs to talk to other pods and other label and environments. Thank you. I mean the namespaces.
that's true. And just to be precise about the statement, the ingress is a one other extra layer that I'm defining in my cluster level, just to avoid keeping multiple AWS load balancer, just to avoid to maintain multiple node ports, right? And you need to define to the ingress saying that how it can route the traffic to the backend actual services that are actually routing the traffic to the pods. That means the ingress controller is not actually routing the traffic to the pods directly. No, it actually route the traffic to the services, right? The
Yeah.
service will take care of routing the traffic to the actual pods. Being said that, now tell me, do I need to use the load balancer type of the service to my applications? You see here I have total 3 load balancer type of services in my presentation so far, right? Do I need to use 3 load balancer type of services? No, right? Why? When I say load balancer type of the service, that actually creates a AWS load balancer for you, right? But here I don't want to create a AWS load balancer for the service that I'm using for my application access. I'm removing this. Is it clear now? Right? Now if you see here, I have got only one service of type load balancer in my Kubernetes that actually take care of having one load balancer at AWS and get the traffic inside a Kubernetes. But what kind of the service that I'm using here to access my application? Now the service that I'm deploying here is called as a cluster IP service. The type is changing now. Cluster IP is the another type of the service that you deploy in a Kubernetes cluster, which is again same responsibility. It is ensuring that it is routing the traffic to the pods based on the labels, but the difference here is the cluster IP service will be accessible within Kubernetes only. It will not be accessible from outside directly. Some time back, the node port service or load balancer type service, both were accessible from outside of the Kubernetes as well, right? Somehow. Now, the cluster IP service will be accessible within the Kubernetes and it need not to be accessible from outside directly, correct? Why? Any traffic that coming from outside is coming to the ingress controller. Ingress controller is now taking the responsibility of talking to the cluster IP services and routing the traffic to them. Since my cluster IP service accessible within the Kubernetes by my ingress controllers, it can be a cluster IP service and that's it. Yes, one ingress controller is enough to handle the traffic routing to all the ports of all the different namespaces too. So pretty much one cluster can have only one ingress controller enough. It can take care of for whole cluster, can be in different namespaces too. Any other questions to me now? It's gonna be logically difficult to understand, hence I put some effort in going back and forth, and that's how it is. can we connect Route 53 to ingress directly? AWS load balancer is the one who is responsible here to route the traffic from outside world to inside a Kubernetes. No other way. Then how would your Route 53 can directly resolute it to a ingress inside a Kubernetes? Understand like this. Anything that is happening in your Kubernetes cluster is completely private, completely within your Kubernetes only. If someone has to access your Kubernetes, it has to go via the node port, and that will be through your AWS load balancer. How the things are going, guys? Are we good? Any questions? Any confusions? Or interesting? Or frustrating?
Hi, PR.
Yes.
If we have only one load balancer for all the environments, for production we'll be having multiple requests. So will load be sufficient for the load balancer as multiple requests will be coming at one time?
Good. If then you maintain one AWS load balancer for non-production, one AWS load balancer for production. I'm saying from the capability wise, from the technical concept wise, one load balancer is enough to get the traffic from outside and give it to inside a Kubernetes, and you take care of the ingress routing. Now it's up to you. You wanted to use one or two or three, right? If you wanted to make your production separated, you maintain a separate load balancer for production. You maintain a separate ingress controller. You separate, maintain the things possible, right?
Yes.
If I go in on next level, right? First of all, the non-production and the production both will not be running in the same cluster. Dev QA perf will be running in one EKS cluster. The production will be running in a altogether different EKS cluster. You will be having two EKS clusters, one for non-production, one for production, guys. As of now, I'm saying that namespaces, everything in the single cluster, right? So when you go deeper and deeper, we are not putting the production it into a same cluster where my non-production is also running. No, it will be altogether a separate cluster as well. Yeah, but yeah, all those are the best practices that will be improving. But from the technical capability concept, yes, one AWS load balancer is enough to handle the whole cluster traffic. But yeah, we can make the changes based on the requirement.
Yeah. In the concepts of that older version of image, when we are creating the new version, then the older version will be present on the worker node and inside the pod, but image will not be running. YAML file will be there. That's it, right?
Correct. That means only the revision will be get saved, but it will not be in a running state, the old one.
Okay, so it does not consume more space, even like just the files will be in small KBs or something.
Correct. Even that is there in your etcd database.
It is there in
etcd database because the replica set controller having this revision or having this YAML configuration, that is just a data, right? So that will be there in the etcd database.
Yeah, and one more thing, logs will not have any effect with this, right? As it's a different thing completely. It just stores the information then and there.
Which logs that you are referring through?
Like if we make any changes, like the upload thing, like that, the dynamic things.
Your pod is completely destroyed and the new pod is getting created here. So whatever the data that was there in the pod, everything is gone. Then where are you getting, like, how are you getting the logs now? Getting me? Sorry. Let's say as of now, I have the pod currently running here. And someone is accessing my website. The logs are getting created in the same pod, correct? The logs are getting created in the same pod.
Yes.
Whenever you do a update as part of the rolling update strategy, all these pods are getting destroyed and the new pods are getting created. All the logs what were created in the previous pod, all the logs are gone and you are getting a fresh new pod altogether.
So if we want to have the logs, we need to put it, mounting concept will come into picture, right?
Yes, that is our next goal. We need to do that.
Okay. Yeah. Yeah, Pierre, thank you so much. Like your presentations are helping us more to understand.
Yeah, thank you. Well, any other questions, guys, to me? And
This ingress controller is from Kubernetes component or external one?
okay, good point. The ingress controller, actually that is the outside of the Kubernetes concept. Okay, ingress is the ingress is the Nginx concept. Nginx is the open source software. The Kubernetes is getting, or the Kubernetes is taking the advantage of the Nginx concept and they are fine tuning that as per their own requirement. It's kind of a tailor made, and they are making that as a ingress controller. You getting me? That means the ingress controller is actually a Nginx. Tomorrow I'll do that deployment. Ingress controller is actually a Nginx. Nginx is the open source software which will do this kind of a routing, the path based routing, right? So the Kubernetes is actually taking that Nginx, which is the open source software. They are doing some tailor made. They are converting that it into their own specific needs, and they are calling it as a ingress controller. I would say simply Nginx application plus load balancer type of the service is equal to ingress controller.
Thank you, sir.
Thank you.
Hi, Pierre. Do we use the replica set concept for the non-production even because it is just for the testing purpose?
The replica set controller is mandatory. Without a replica set controller, your pods will never be get deployed because all the pods are actually getting created using the replica set controller only from the Kubernetes concept perspective. So you always deploy the deployment. Deployment take care of creating a replica set. Replica set will take care of creating a pod. That's
Okay. Maybe we can give the value as one just for non-production.
correct. So you
Okay.
just maintain the replica count how much you want. Probably yes. In the non-production, you make the replica count as 1. The production, you make the replica count as 3 or 4. That is true. But we can't avoid this replica set controller. That's the fundamental concept of Kubernetes, how it is managing this whole stuff.
Yeah, the template, the flow will be the standard thing. We cannot change anything.
Yes.
Yeah, got it. Thank you.
Thank you. And yes, all these slides, whatever I'm presenting, are purely custom slides that I have made myself, guys, just to think. This is how I think that this could be the easiest way to understand. Nothing that I can get from Google, all the slides. No, I think none of the slide I can get directly from the Google. It's all made by myself with the custom presentations. Thank you. Okay, if no questions, we are good for today. We'll regroup tomorrow. We'll try to deploy the ingress controller.